Hello YouTube viewers, hope you're all doing good and welcome back to this Learn Kubernetes series. In this video I've planned to show you a quick video. This is going to be a very quick one, and I'm going to show you how to create pods, how to create replica sets and deployments. If you have not been following my series, I would advise you to follow this playlist, Learn Kubernetes. So the fundamental step is to get your cluster up and running. So I've done a couple of videos. One is setting up Kubernetes cluster using kubeadm command. That's done manually. You have to have your machines ready, and you can do the initialization and cluster joining using the kubeadm command. And I've also done another video on setting up Kubernetes cluster, where you can use Vagrant for provisioning the virtual machine automatically using VirtualBox as the provider. It's all in my GitHub account. If you follow my video, you should be able to get the cluster up and running. So in this video, I'm going to show you how to create a pod using a YAML file, how to create replica sets, what's the difference, and then finally, how do you do the deployments. Right, as usual, I'm going to bring up the cluster now. As you can see in my virtual machine, I haven't got any virtual machines, so let's set it up. I'm going to cd to my play directory. I'm going to clone my GitHub repository, cd to Kubernetes, and then to Vagrant provisioning, and do Vagrant up. This is going to take a while. I think it will take like 6 or 7 minutes on my machine. I'm going to pause the video here and I will resume it when all the machines have been provisioned. Alright, Vagrant has provisioned us the 3 virtual machines, 1 master node and 2 worker nodes. I'm going to copy the configuration from kmaster, the Kubernetes configuration, so that I can run the kubectl commands from my host machine instead of logging into the kmaster. So I'm going to make a directory called .kube under my home directory, and I'm going to copy etc kubernetes admin.conf to config under my .kube directory. Cool, that's copied. Let's check the status of our cluster. kubectl cluster info, that's running. kubectl get nodes. Right, all our nodes are in the ready status. Okay, so now we've got the cluster running. Let's go one directory above, and if I do ls, there is a directory called YAMLs. cd to YAMLs. So we're going to be looking at these 3 YAML files in this video. Don't worry about the YAML if you don't know. YAML is yet another markup language. It's a superset of JSON. So I'm planning to do a video on YAML syntax, how to create YAML files. So we'll come to that in my future video. So for now, let's first try creating a pod. A pod in Kubernetes is the smallest deployment unit. So you can write your application. You can deploy your application. So the smallest unit is going to be pod. When you create replica sets and you define, I want these many instances of my application running, it's going to create that many pods on the cluster. So for example, if you take Nginx, if you just deploy one Nginx, and if it's gone, that's it. So that's why I have to create a replica set. So a replica set basically creates multiple pods based on the configuration you give it. So a pod can have more than one container. For example, if you're deploying a web application, possibly with a database backend, so you want to deploy Nginx or Apache as a container and MySQL as a container, although in theory you could put the MySQL and the Nginx or Apache container both in the same pod, it will work. But when it comes to scaling or auto updating, it's not advisable to have two containers in a pod. So just go with one container a pod. If you deploy Nginx or Apache on a pod and then MySQL on a different pod, on a different deployment actually, you can scale independently. So if you put both these together, and when you want to increase the number of instances of Nginx, because you have deployed them as a single pod, when you scale it, it's going to scale both the web part as well as the MySQL container, which we don't want. So it's better to have one container per pod. Okay, let's look at what's in the YAML file. First, I'm going to open up nginx pod.yaml. Cool, that's very simple. So it's the simplest of the YAML file. I'm taking Nginx as an example in this video. You could do any container here. So these are the minimum things you need in a YAML file for pod resource. So what API version we are going to use and what kind of resource we are going to deploy. In this case, we are going to deploy a pod. Metadata and the pod specification, the container specification. So pod is the deployment, metadata, the only requirement. There are lots of things you can include in the metadata. For example, you can add a label to your pod. When we come to deploying the replica set, we'll come to know how to create labels, how to assign labels, because that's how the deployments and the replica set knows which pods to manage. For example, if you deploy a replica set with 3 replicas of Nginx running, so how do that replication controller know this replica set is going to manage these 3 pods? So that's where you assign the labels. Excuse me. So based on the labels, it selects the pods are grouped under one replica set based on the labels. As we are deploying a very simple pod, I haven't included any labels yet. And the specification, what container template you're going to deploy. The image I'm going to deploy is Nginx image, and you need a name for it. You need a name for the pod, so I'm going to name my pod Nginx, and I'm going to name my container Nginx. You can name whatever you want. So that's the pod. Let's see how it works. Okay, I'm going to open up another pane here, and on the top pane I'm going to do kubectl get all minus o wide, and I'm going to watch that. As you know, the Kubernetes service, that's the default service, and we haven't got anything else running on this default namespace. cd to play Kubernetes YAMLs. Let's try creating this pod. kubectl create -f nginx pod.yaml. So it says the pod nginx is created. You can see here pod nginx, the container is getting created now on the node kworker1. So that's quite simple. You can use kubectl get events, I think. Yeah. Starting kubeproxy, pulling image nginx. kubectl describe pod nginx. It's given some detailed information about it. So now we can see the pod is running. So that's just a pod running. It's of no use because you won't be able to access the pod or the container within the pod if you don't create a service. So I think in my previous video running Docker containers in Kubernetes cluster, I've showed you how to create a service, expose a deployment on a particular port using node port so that you can access it, access the Nginx application running. So that's not the aim of this video. This video is about understanding pod, replica sets and deployments. So that's running now. If that pod is gone, it's gone. That's it. If you kill the pod, kubectl delete pod nginx, you can do it this way. So that's gone. Or you could have done kubectl delete -f, the actual file you used to create that resource. So anyway, that's gone. That's it. Your application is broken now. Your application is down, so nobody's gonna access your application. So what you want to do now is to for failover or for load sharing, you're going to deploy multiple instances of Nginx. That's where the replica set comes into place. So we've got a replica set. Let's look at what the YAML looks like. Again, it's simple. The basic things. I've removed all the other optional values that are not necessary just for the sake of this video. So you need that API version, kind. We are deploying the replica set resource, metadata. The name of the replica set is Nginx replica set. And here, if you notice, I've included the labels run Nginx. I'm applying a label called run, and the value of that label is Nginx. And all the pods created using this replica set will have that label attached to it. So when you scale a replica, when you scale it up or scale it down, if you add more replicas to it, it knows which pods to manage. And we have defined how many replicas we want. So in this case, we want 2 instances of Nginx running, basically 2 pods of Nginx running. Selector, so how does it select? So this label here, it just applies the label to all the pods created by this replica set. And this replica set manages all the pods based on this selection criteria. Wherever the pod has the label run with the value of Nginx, that will be managed under this replica set. And the template. So you've got the metadata for the template, you've got the container specification, which is same as the pod.yaml. Let's close this one and start creating the resource. kubectl create -f nginx replica set.yaml. Replica set created. So now you can see 2 resources. One is the Nginx replica set. The other is the pods that gets created by this replication controller. You can see here the desired count is 2. Currently we have 2, and we have 1 in the ready state, which is this one, and the other one is getting created. This one was quick. That's because on node kworker1, when we deployed the pod with the previous command, it already pulled the Docker image for Nginx. So on kworker2, that image didn't exist, so it's going to download the image from the Docker Hub. So now it's running, and the name for these pods are Nginx replica sets and so on. You've got the replica set running. We've got 2 in the ready state. So now if I kill one of them, for example, kubectl delete pod Nginx, say for example if I delete the pod running on kworker1, you can see that's getting terminated. And as it's managed by a replication controller, where we specify the desired state to be 2, it always maintains 2 instances of Nginx pod. So as we deleted one, it created another one. So now we can see again it creates 2 instances of Nginx. So let's delete the other one. Delete pod. Let's delete the one that's running on kworker2 node. So we are terminating that, and it creates another one. So that's the advantage of using a replica set. So if a node crashes, or if the application doesn't work properly, I will also do a video on the pod health check and the liveliness check, readiness check. I think it's readiness check, liveliness check. Yeah. If a pod goes out of service for some reason, even though the node is still up and the pod is running, but it's not serving any web page or anything, we could define a health check. Say, for example, if you go to this URL on this container, it should show you this page. If it doesn't show that page, assume that the pod is broken. Assume that the service is not running or something is wrong. So what the replication controller will do is just delete that pod and then create another pod, and then it waits for the pod to become ready. So that's replication controller. Replica sets. Let's delete it. kubectl delete. Let's delete the pod. 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 Let's delete replica set nginx replica set. That got deleted and these two are getting terminated. Okay, so what's the final one we've got? The one we've got is deployment. So why do we need a deployment instead of replica set? Right, the advantage of using deployment is when you deploy your application, you would want to update your application. You want to do a rolling update. For example, you've set up a deployment of Nginx web application with 5 replicas, and you decided to use use an updated version of Nginx. The Docker image uploads a latest image of Nginx, and you want to update update the Nginx to the latest version, and you don't want to break your web application. So what you can do is you can roll out the updates one by one or two at a time, depending on how you configure your deployment. When it comes to deployment, you've got options in the YAML file where you can say, I want at any given point, I want 25% of my replicas to be available. So when it comes to auto updating, rolling out the updates of the latest Nginx, it always makes sure that it has got like 25% of the replicas available and ready for servicing in service. So that's the advantage of using deployment. Let's look at the YAML file. vi deployment.yaml. It's again very simple. It looks very similar to the replica set. When you create a deployment, it automatically creates a replication controller, replica set for you. So you don't have to create a replica set. API version, we are deploying a resource of type deployment. Metadata, we're going to add attached label run with the value of nginx to all the pods created in this deployment. I'm going to name this deployment nginx-deploy with 2 replicas and the selector. I want to select all the pods matching this label under this deployment, and the pod template and the container specification. So it looks very similar to the replica set. Let's deploy that. Okay, deployment.yaml, deployment created. So now you can see that's the deployment. We configured the name to be nginx deploy, and the deployment has automatically created the replica sets. So we haven't given a name to the replica set. So it has done the name automatically. It has generated the name automatically with 2 desired, 2 current, and 2 are in the ready state. So it was quick because we already got the Docker image for Nginx on these machines. And we've got 2 pods running. Let's try deleting one pod. kubectl delete pod Nginx. So that's getting terminated. Another one is getting added. Okay. Cool. And let's look at the details of a pod. I want to show you some things. Describe pod. Let's pick up one of the pod. Okay, as it spits out lots of information, I'm going to pipe that through the less command. Okay, so that's the name of the pod, and it's been deployed on the default namespace. On node, that's the IP address of the node, what time we deployed it. You can also see it here, how long it's been running, age. Since we deleted that pod, this one got created recently. That's having a low age. Status is running. What's the IP of the container? 10.244.2.5. And this is the interesting bit, controlled by. So what is it controlled by? If you want to know what a replica set, which replica set is managing this pod, you can see that controlled by replica set nginx deploy. That's the same as this replica set. And you have the container details. Container name is nginx. We've got that Nginx image status is running when it started, and the readiness state, is it ready? Yes, it's ready. And restart count, environment, mount, so on, condition, and so on, node selector, tolerations, and the list of events here. Okay, so let's look at what's in the replica set. kubectl describe replica set nginx deploy, pipe that to less. That's the name of the replica set. Again, it's in the default namespace. Selector, so the only thing we did when we deployed the YAML file was to attach a label called run. So these two pods will have a label run equals nginx. Labels run equals nginx, and this gets auto-generated when you deploy an application or a container. So controlled by, so this replication set, did we create this replication set manually or did it get created automatically? This is the way to find controlled by deployment nginx deploy. Replicas to current to desired to pod status to running, pod template, and details about the container and the events. Okay, so what if we didn't start these nginx replicas as a deployment? If we did it like the previous command, directly deploying as a replica set, you won't see that. Okay, let's look at how to find out the list of pods with the label run equals nginx. The command is kubectl get pods -l run equals nginx. So we now have, if you've got a real production cluster, you would be running lots and lots of pods, containers, deployments, replica sets. This is the easiest way to find out which pod. If you know the label, you can filter it using that label. And if you look at one of the pod, you can go from there and grep for controlled by and gives you, okay, so now we've got these pods, and these pods are managed by this replica set, and kubectl describe replica set grep for controlled. So controlled by. So now we come to know that replica set has been deployed automatically by this deployment. Right. That's the pod replica set and a deployment. It's better to use the YAML file. And if I do kubectl scale deploy nginx deploy -replicas equals 3, that's going to create another container. So that's how you increase the amount of replicas running. How did I create these YAML files? ls. So basically all these YAML files, how did I create? I think I've explained to you in one of my video how it's easy. Either you can, if you know by heart what you want, it's basically 4 things. One is the API version, kind, what the actual resource you're trying to deploy, metadata, which contains the name of the deployment, name of the resource you're going to deploy, and the template, the specification of the container or the pod. If you know by heart, you can write YAML file yourself, or the easiest way is if you look at kubectl, if you're starting fresh, let's delete it. Let's delete the deployment. Kubectl delete deploy nginx deploy. So all these pods are getting terminated. And if you're starting fresh and if you want to write an YAML file, just look in the kube system namespace, kube system -n for namespace, kube system get pods. So these are the cluster related pods, the DNS service, etcd, that's the data store, API server, controller, flannel, proxy, scheduler, and all those things. You can look at one of them. kubectl get pod. You got to specify the namespace again. Kube system get pod. For example, if I do kube proxy, and I want the output in an YAML file, and that's going to give you the YAML version of it. Just save it in a temporary file, mypod.yaml, and if you edit that file, mypod.yaml, and basically you've got your YAML file, and you can go ahead and update it. If you don't know how to write your own YAML file from scratch, you can just copy one of it, export it as YAML file, and you can delete things that you don't need. Name, kubectl. That's how I ended up creating these 3 YAML files. And you don't need lots of these data. I don't need status, so I'm going to delete everything underneath. And this is how you generate your YAML file. I personally do this way. It's easy. You won't make any mistake. Right, I think that's it I wanted to show in this video. This one, I don't know how long it took. Okay, if you've got any questions or comments or any feedback or any problems running this through, just leave me a comment and I'll be able to respond to you. And I would recommend you watching my previous videos. If you can start any video in this playlist, Learn Kubernetes, but because every video I'm starting by bringing up a new cluster, so that new viewers, when they come to watch one of these videos directly, I don't want to start by saying, okay, this is the cluster and I'm gonna start deploying everything. So that's the reason I'm bringing up the cluster every time I'm starting a video. But if you want more details on the cluster setup, I've done 2 videos as told earlier in this video. If you search Learn Kubernetes in my channel, just me and open source, you should be able to find it. Right, I think that's it. I'm planning to do more videos on cron jobs, daemon sets, using Helm. Helm is a package manager. You can deploy application easily without writing a single line of YAML file. So there are lots of interesting videos coming. I'm planning to do one every week, or if I'm more energetic, interested, I'll do 2 or 3 in a week. Okay, hope you learned something today, and thanks for your time watching this video, and see you in my next video. Bye bye.